Buenas tardes a todos. Les solicitamos ocupar sus lugares y guardar silencio. Asimismo, les comparto que tendremos un espacio de preguntas y respuestas en donde el doctor Ronald A. DePinho podrá resolver sus dudas. En nombre de la Escuela de Medicina y Ciencias de la Salud, TecSalud del Tecnológico de Monterrey, les damos la bienvenida a Gigantes de la Medicina. Nos da mucho gusto compartir la experiencia de los grandes talentos de la medicina y ciencias de la salud a nivel internacional. Enseguida, presentaré a las personalidades que nos acompañan esta tarde. El doctor Guillermo Torre, rector de TecSalud y vicepresidente de investigación del Tecnológico de Monterrey.
Gracias.
Nuestro invitado de honor, el doctor Ronald A. DePinho, profesor distinguido y expresidente del Departamento de Biología del Cáncer en MD Anderson Center, Universidad de Texas. El doctor Luis Alonso Herrera, decano de la Escuela de Medicina y Ciencias de la Salud del Tecnológico de Monterrey. Y el doctor Manuel Pérez, decano Región Monterrey de la Escuela de Medicina y Ciencias de la Salud, TecSalud. Sean ustedes bienvenidos. A continuación, cedo el micrófono al doctor Manuel Pérez para que nos presente la trayectoria de nuestro invitado especial. Adelante, doctor.
Muy buenas tardes a todos y muchísimas gracias a todos y a todos por acompañarnos en este programa de Gigantes de la Medicina que ya tiene una tradición casi de 7 años y que siempre nos esforzamos por tener distinguidas personalidades como la que hoy nos acompaña aquí, el doctor Ronald DePinho. Muchas gracias en particular por su generosidad, el darnos su tiempo y seguramente darnos sus comentarios e ideas que en un momento nuestro rector charlará con él. I'm going to switch to English to thanks Dr. DePinho for being here. Thank you very much for your time, your knowledge, your comments, and I'm sure that we'll have a wonderful session this evening. Dr. Ronald DePinho is the past president and distinguished university professor at MD Anderson Cancer Center in Houston, Texas. He studied biology at Fordham University, where he graduated salutatorian, received his MD degree with distinction from the Albert Einstein College of Medicine, and performed his residency and postdoctoral training at Columbia Presbyterian Medical Center. His research career began at Einstein and Feinberg's Senior Faculty Scholar in Cancer Research and ACS Research Professor. He then joined the Dana-Farber Cancer Institute and Harvard Medical Center, where he was the founding director of the Belfer Institute of Applied Cancer Science. During his 6-year tenure as MD Anderson president, Dr. DePinho conceived and launched the Cancer Moonshoots program, enhancing MD Anderson's research and training excellent, recruited many world-class faculty, including the first Nobel, and expanded its global network to reach 1/3 of the human population. His research program has made fundamental contributions to our understanding of cancer, aging, and degenerative disorders, and these discoveries have led to clinical advances. For these contributions to cancer, aging, and healthcare, Dr. DePinho has been received the AACR Close Memorial Award, the Albert St. George Prize, the Ellis Island Medal of Honor, Portugal's Order of St. James of the Sword, among other awards and honors. He is a member of the National Academy of Medicine and the National Academy of Sciences, and a fellow of the American Academy of Arts and Science, the American Association of the Advancement of Science, and the American Association of Cancer Research. This is a brief summary of Dr. DePinho's CV, and now I'll let the talk with Dr. Torre, our president of TecSalud. Thank you again, Dr. DePinho. We are honored with your presence here.
Thank you. Gracias, Manuel.
Quite an introduction.
I know. So the idea is for me to enjoy it because I am a frustrated Larry King. I enjoy this. So Manuel and I and Jorge, who was the former dean of the medical school, we kind of decided that we wanted to do this with the objective of sharing the experience of very accomplished individuals to our community of students and faculty, which I think is really important. So I will start by asking you some questions, and then we'll go from there. And wherever you want to go, we'll go. And I have some ideas.
Oh, fire away.
So I think one of what's really attractive to many of us is to see what was your life like before you went into med school, and how we probably have students, if not now here, but in the very early stages of med school. So what was your growing up like that made you eventually decide to go into med school? Maybe you can tell us about your family growing up, whether you have parents that were physicians or in medicine or research.
Far from it.
Far from it.
First of all, let me say what a privilege and an honor it is to be here at the medical school. I've admired this medical school from afar. I had an opportunity to visit the campus. The Health Science Center here is really excellent, and I congratulate all of you on such an excellent institution and TecSalud. So congratulations. So I did not come from a conventional, my parents were physicians and so on. My parents were poor, uneducated Portuguese immigrants to the United States. And we grew up in a household. We were always, loved and supported. Education was very important. And my oldest sister was the first person to graduate from college in my family, the entire family. So for me, my passion for science and medicine began as a sophomore in high school when I dissected my first frog. And I opened this creature up, poor creature, and I wanted to understand, how does this possibly work? And I was instantly addicted to biology.
And that was in high school?
That was in high school, and I really wanted to, and I loved people. I knew I wanted to do something with people. And so I thought, and this was with no guidance because I had no role models, maybe a career in medicine was a career that I would like because it would bring together biology and the ability to really connect with people and form this very special bond that a physician, a healthcare provider has with their patient. And then, so I then went into college and I focused on biology. I majored in biology. And I loved it, and that reinforced my interest in biology. And then from there, I went into medical school. And I loved clinical medicine. I do to this day. And for me, I became increasingly interested in trying to understand what causes disease, not just how to treat it. So those are kind of the evolution of my journey that put me in the position of being both a physician and a scientist.
And you grew up in New York, you went to school at Fordham and then went to Columbia.
Yes.
And then how did you end up in Boston?
Well, so first, my journey, I went to Catholic education. And so the schools that I went to had deans of discipline. So that was an interesting...
Fordham is Jesuit.
That was Jesuit. So I was, I had the Sisters of Charity during grade school, Marist Brothers during high school.
I did that too.
And then I had the Jesuits, who oftentimes my teachers would have 3 different PhD degrees. And then I went to Jewish medical schools. I was completely confused because then I had rabbis. And then I went to Columbia Presbyterian Medical Center. So I had a very interesting journey. And, actually what was interesting about New York for me was the diversity of the culture. And I really got an appreciation for, different cultures and different customs and so on through the lens of the experience of New York. And then I started my career after my training at Einstein as a medical student, and then Columbia for my postdoctoral training and residency. I then started my career at Albert Einstein College of Medicine, where I focused on cancer and aging. And the reason for that is I was interested in why age causes cancer. And so we were very interested in trying to understand and answer that basic question, because it's the most important driver for cancer. And so that program was very successful. And then my interests expanded more and more in cancer.
So your telomerase work started back then?
Yeah, back at Einstein. And
we should talk about more on that specific later.
Absolutely, it's very important. Obviously, a Nobel Prize was given out for telomerase, and so it was, for me, I was interested in having a broader arena, and Harvard was beginning to bring together 7 different institutions in the Dana-Farber Harvard Cancer Center. And this was going to be one of the largest cancer centers in the world, and it was going to be across all the Harvard institutions. And then I went to a meeting, a very special meeting, with fancy scientists, and in Italy, and David Livingston, who was the chief scientific officer at Dana-Farber, Harvard professor, very famous icon in cancer. He is truly a giant in medicine. He unfortunately passed away this past year. So David, I gave my talk, and he said, well, why don't you come and visit us at Harvard? I think this would be the right place for you. And I went and I visited, gave some lectures, and realized that was an environment where I'd be able to really achieve the sorts of things that I was very interested in. So then I left Einstein, left New York. Nobody ever thought that a diehard New Yorker would leave New York, and so I left and I went to Boston.
Houston is probably a bigger step for anybody from New York, but
surprisingly, it's actually more like New York than Boston. Boston is a small town. Boston is special in that it's a really amazing environment where you have really, I think it's the Florence of our time with respect to life sciences. It is a very special environment. And so I went there, and then from there I established my laboratory, and then I became increasingly interested in trying to improve the accuracy of cancer drug development and using science and genetics. Back then, genetics wasn't used to shepherd drug discovery.
This was probably in the 80s, or?
This was in the late 90s.
Late 90s.
Late 90s, and the human genome project was just being finished. But we had no clue as to what the spectrum of genes were in cancer. Back then, we probably only knew about 3 to 5% of the cancer genes. So we're at the very, very beginning, but we didn't realize that. But as somebody who studied cancer genomes, it was obvious to me that you couldn't simply develop a drug for lung cancer. You had to develop a drug for lung cancer with specific mutations. And so we developed this concept that led to the Foundation for Targeted Therapy. And so with that knowledge, I then started this Institute for Applied Cancer Science, using science to identify targets and drugs against those targets. And so that was the Belfer Institute at Harvard and so on.
Which, for everyone here that's oncology or training in oncology, that's the norm today. Yeah. Even I'm far away from oncology. But I have to tell you a personal story, because I guess, I don't know if anybody knows here, but I wanted to be an oncologist. But I guess Houston transformed me, changed my life to become a cardiologist. But I really wanted to be an oncologist. Yeah. We'll talk about that later. But so I think it's fascinating. So maybe not, it may not be intuitive for everyone, but I'd like you to tell us, was at some point a decision in your life to become a medical researcher versus a physician caring for patients, or did you have to make a decision at some point in your career? Did you do one or the other? You maintained both for some time, or how was that decision for you? Because I think it's a question that frequently those students, residents, or your faculty that want to do research may have to solve at some point.
Yeah.
So how was that for you?
Well, for me, you know, I had a little bit of research experiences throughout my college and medical school, but it was very, very minimal. But as I remember my first night as an intern at Columbia, I got a patient with multiple myeloma and hypercalcemia. And I thought this was really fascinating. And I had another case that was a case where this individual who was an IV drug abuser had all these weird infections, cryptosporidium. And so I went into the library there. At that point, there were only 6 reported cases in the East African Journal of Infectious Disease. And so there was I was very interested in not just figuring out how to take care of these patients, which I love to do as a clinician, but I increasingly became interested in trying to understand what actually causes these diseases. And that patient, by the way, Mr. Mendez, turned out to have HIV. We didn't know it at the time. And so this was, this fascination with disease, but really trying to understand its underpinnings, not simply understanding how to treat them. For the students, currently, because of our knowledge of the genome, there are an estimated 10,000 diseases that are known to humankind. We only have 500 treatments and cures for diseases. So all of you that are starting your career, you're going to be faced with the challenge of dealing with and figuring out the other 9,500. So this is an exciting time because we now have the technology to be able to make a decisive assault on a lot of these things that are causing a lot of pain and suffering for people.
So oncology, I think, or cancer research, maybe it's my bias, but I think is one of those areas of medicine that was at the forefront of bringing multiple disciplines to answering a problem. At least me training in cardiology, I always looked at the cancer researchers as in the forefront of research, and frankly, we were always behind it. And like understanding of molecular biology into cardiovascular medicine, it took years after the oncologist or the cancer researcher, inflammation, and so you name a number of things. But today, I think the understanding of one field can be easily adapted to others.
Yeah.
So if you look into the future, and I think this is obviously a sort of a hypothetical question, where do you think will be the most fundamental changes in cancer research? Are we really going to be able to tackle a fundamental problem that can abort the variety of cancers, or
Yeah.
and where are we going to find that holy grail for cancer to solving the cancer problem?
Yeah, so I would, I say this with humility. When I started my career 40 years ago, and I started, my postgraduate education, et cetera, back then we thought of cancer as simply one process, which was one cell becomes 2. And it's just a matter of cell division. There was what's called hallmark of cancer. Today, there are well over a dozen hallmarks of cancer. Sequestration from the immune system, causing new blood vessel formation and angiogenesis, so on and so forth. And even just 10 years ago, there were fewer hallmarks that we were aware of. And so when you look at that, you realize quite rapidly that we always have to remain humble in what we think we know. We now think we have a very good understanding of what causes cancer, that it's, disease of the genes, et cetera. But then you have things coming in where the gut microbiome dramatically affects the development of cancer. In fact, is a co-conspirator with cancer cells in the tumor microenvironment to regulate tumor biology. And so, we're constantly humbled by these new advances that are the source of Nobel Prizes in the future and so on. I think what gives me confidence and why I launched this initiative called the Cancer Moonshot that was alluded to earlier is, and this was 10 years ago, and that was that for the first time with immunotherapy, we were beginning to see cures of advanced disease. And that to me was a game changer. Because up to that point, We had chemotherapy, RT, of course, for surgery that led to a substantial number of cures. We also had the advent of targeted therapy, where we have a genetic mutation, we have a drug that is squarely directed against that rogue aberration, and we see very impressive responses. However, they're transient because the cancer is highly plastic and can change very rapidly, et cetera. But when immunotherapy came about, and Jim Allison, who won the Nobel Prize, was the first recruit that I brought to MD Anderson.
Was he up in New York or
He
Boston?
was in New York.
In New York.
Yeah. There was
For those that he won the Nobel Prize for immunotherapy of cancer. For those of you, I mean, I don't know him, but I follow his story. So we came to MD Anderson, and
Yeah.
that.
And so, I thought that Jim was going to be very important. And what we were seeing with those early, so we knew melanoma, which has a lot of mutations. Everybody always expected that immunotherapy was going to work eventually for melanoma. And so what Jim discovered was a break on T cells. T cells are the cells that actually kill cancer cells, but they're asleep because of a break. And he discovered the break, and he developed a drug against the break to deactivate it, unleash and reawaken the T cells to fight cancer. And so what was very interesting to me around that time is that not only were we seeing this in melanoma, but early stage clinical trials were showing very impressive Lazarus results in patients with kidney cancer, lung cancer, and so on. So this to me was the game changer, and I realized, and I made a prediction back then, that 80% of patients by the end of the decade were going to be on some form of immunotherapy. Didn't quite get there, but it was pretty close.
Yeah, it seems
And
like
now
almost every form of cancer.
Exactly,
will receive
exactly.
some- Amazing. So I follow, like this story of immunotherapy is very attractive to me. So I'll take the opportunity as sort of a personal question. But I follow years ago with a lot of interest the work by Steven Rosenberg at the NIH. And he worked with these lymphokine activated killer cells, which it was a very primitive form of immunotherapy, just not stopping the break, but just making them more active by feeding them growth factors, right? So that never really went anywhere, right?
Well, it did to a certain
just-
extent, and it does work in patients, these what's called tumor-infiltrating lymphocytes. So you basically take the T cells that are there, but they're exhausted and they're feeble. And so in a sense, what Jim did, but did it with a drug, and he discovered a mechanism. So he got the Nobel Prize, and you get Nobel Prizes for illuminating new biology. So up to that point, people only thought about what turns on a T cell. Nobody ever thought, oh, something has to actually turn it off. And then he discovered the off switch, and then he thought one step further, and he said, I wonder if I deactivate it, I can now re-awaken. So,
them more active.
but what Steve did was he took out the cells that were in the tumor, and he used in vitro, outside of the body, growth factors that can then expand the cells and create, trillions of these T cells, these soldiers, and then reinfuse them back into the patient. And it worked in some patients, but not all patients. So, but we really didn't understand why. And what we know now, and what's very exciting, and I think in this next 10 years in cancer, so the last 10 years have been about T cells and taking the brakes off T cells. But right now, only at most 25% of patients are cured. What is going on with the other 75%? It turns out that there are other levels of regulation, other breaks in the immune system. So are these cells called myeloid cells, tumor-associated macrophages, myeloid-derived suppressors. Those cells are actually even more important in dampening the immune response in the tumor. And so what you're going to see now over the next 10 years is lots of drugs that are unleashing the brakes on the myeloid side. And those are going to, together with the T-cell checkpoints, I think we're going to increase the response rates to advanced malignancy tremendously as a result of this. So targeted therapy, T-cell checkpoints, and then myeloid checkpoint is going to be very important.
I suppose on the other the other side of the coin will be that there probably be more autoimmunity.
Yeah, that's right, and
Right,
it's a big
so-
issue. It's a big issue, and I think you need to reawaken the immune system, particularly in the tumor microenvironment. I think this is going to be really
That would be the
interesting.
key.
You know, and not get the systemic side effects, et cetera. However, there are ways to manage patients so that they don't get the colitis, pneumonitis, and other problems, myocarditis that you're seeing in your clinic, that there are ways to attenuate that, especially if you catch it early.
So is Nestor here? One of my colleagues here, I don't see him here, but he did a series of experiments in mice. And if you do dual immune checkpoint inhibitor in mice that are perfectly healthy, they don't develop autoimmunity. But if we injure them selectively, so they will develop either myocarditis or nephritis, or so it's like the pre-existing of a neoantigen is required in, we believe, in the adult population to have the autoimmunity. That
Yeah, and
anyway,
that makes perfect sense, because what you're doing with checkpoints is you're disturbing the balance of the immune system. The immune system is regulated in a very homeostatic way. You get an infection, you want a robust response that's specific to the infection, and then you want to turn off the immune system. So there are multiple gas pedals, multiple brakes to regulate the entire system under different physiological states. So what we're doing with some of these immune therapies is we're reawakening the immune system, and all bets are off, because it's not just the cancer that gets attacked, but the patient as well. That's why adverse side effects is a new area. What's very exciting, actually, is that a paper that was recently published from MD Anderson shows that at least some of the side effects could be neutralized by neutralizing IL-6, which is a cytokine that causes a lot of
pro-inflammatory.
exactly,
Sure.
it's a major inflammatory.
So I can probably, which we will talk more later, but I'm fascinated with this. I'm honestly a frustrated oncologist. I really, I went to train at Houston so that I could go to MD Anderson to be an oncologist.
We'll still welcome you back.
Yeah, but I worked closely with Janet Rowley at the University of Chicago.
A giant.
I did work with her husband, and I knew her very well, and she would come in as a very famous woman scientist, much more famous than my professor, who was her husband. She was very sweet, very kind, and I spent a lot of time with them. And she would come to MD Anderson and come to my house. And so I became fascinated back then, because she's one of those individuals that discovered new biology. She defined that the Philadelphia chromosome, there was this identifying marker for one of the leukemias, was the result of genes that jump from one to the other, that activate and make the cells proliferate.
Yeah.
So that was an open. I don't know why she never really won the Nobel Prize, but
You know,
I guess it doesn't matter, but,
yeah, it's just the cue, right? So
yeah. But anyway, so we will talk more about oncology, but there is something in your story that I want you to tell us about, and I also know, just by did a little bit of my work before I knew I was going to talk to you. You've been in a couple of commissions at the Vatican. And so I'm very curious to see what is it that you do and what led you to be active in that area. And do they consult you because of your wisdom, because of oncology, or just the Vatican Council on Ethics or medical things? They just need people from a variety of backgrounds to give opinions. And so I thought that was fascinating. So I kind of wanted you to tell us a little bit about that.
Yeah, so the Vatican is really interesting in that most people think, they're not as interested in science and really trying to understand science. Of course, the Galileo, experience really colored how people think about the church. But the church is incredibly interested in trying to understand science and its application to humanity and reducing pain and suffering. And so I was involved in a meeting that initially was a stem cell meeting that was organized by this very gifted physician, Robin Smith. And Robin asked me to help her organize these meetings. It was on stem cells and trying to understand, should we really be using embryonic stem cells? Can we just use somatic stem cells? Something that was very important to the church to understand so they can understand their position on this and so on. And so that I was able to convince the Vatican and Robin to shift the emphasis of these meetings away from stem cells to really public health. I'm very passionate about public health and what one can do to actually prevent diseases from happening in the first place. And so what we did is we essentially created a mini Davos. So if you were to centrifuge down Davos, the pellet would be this meeting. So, one year I invited Katy Perry, which really endeared me to my daughters.
You were probably very famous with your daughters.
The Edge, yeah. They didn't know I was going to do this, and I did a selfie with her, and they said, oh my God, it's the first time they ever answered a text. So they were teenagers at the time. And and we had Joe Biden, and we had Nobel laureates. Jim attended, Carl June, which is another, great scientist, and so on. And basically what it was, policymakers, scientists, physicians, and heads of state, et cetera, and people in entertainment and social, to come together and really think about the problems facing the world from the perspective of health.
Those are commissions that occur every year, or
No, we did it every other year, and we stopped during COVID, and we'll resume them again in the near future. But it's been essentially on delay since the COVID situation.
So that's a commission that's appointed by the Pope with a scientific committee.
We typically have an audience with the Pope and so on. And so then, in addition, because of my relationship in organizing this meeting, and some really fascinating meetings, but I'll tell you about one that was really interesting, which is in the hall where they debated Galileo. So this is in the Pontifical Council in the Vatican, where you come together and you talk science, right? This has been for centuries now. We had a debate about CRISPR. Should you change the germline of individuals?
CRISPR, gene editing, just for everybody.
Yeah. And a Nobel Prize was given out for that recently. And so, should you just use it for somatic diseases like sickle cell? Or should you use it for things that are, germline variations? If you have a BRCA mutation and you don't want to get cancer, or ATM or progeric mutation, et cetera, should you change the germline, and so on? So I brought together the CEOs of all the CRISPR companies at the time, the biotechnology companies, the head of the NIH, Francis Collins, and we had folks from the Vatican, et cetera, and we debated this thing. So that's the kind of meeting that it is that we talk about really important issues that the church would like to really better understand from the experts, et cetera. And then, in years past, for Pope Francis, in fact, I had the privilege of writing part of his annual speech, and specifically on health, and one year I was successful in having him articulate the point that disease prevention is a child care issue. Most people don't realize that most diseases, the seeds for disease are planted during childhood. It's not, even though it manifests in the adult. Think about most adult smokers start as children. HPV vaccination to prevent cancers, you have to vaccinate when you're 11. Early UV exposure causes melanoma later in life, and so on and so forth. So these are all child care issues, and vaccination was an important issue. And so I was very pleased to see that, he was able to express that point of view.
That's really exciting. Without going too much into politics, but we touch on science, public policy, and during COVID, not only in the U.S., but we saw it in Mexico, and I guess I didn't really follow Europe that much, but the intersection between politics and science, where things don't add up.
Yeah.
How much do you think is the responsibility of those that are in science or leading organizations that have a say should actively be confronting public policy issues?
I think it's one of our solemn responsibilities. We have to, first and foremost, educate policymakers. So I'm proud to say that, we were involved in convincing in a bipartisan way in the United States to pass the Tobacco 21, which raised the age of tobacco purchase from 18 to 21. A single law that will save 57,000 lives per year, $38 billion in healthcare costs per year, right? So policy is extremely important. It's also important for us to do our best to educate, but to the public to understand the importance of vaccines, to understand the importance of prevention measures, et cetera, or the harms of alcohol, the harms of tobacco. It's our responsibility to educate the public as well. And to do so in a way that really helps us understand their fears and their concerns. And so we have to be much better. I think the scientific community really needed to do a better job in communicating to policymakers, communicating to the public the importance of really taking care of themselves and getting vaccinated in the case of COVID and so on. So we have a long journey ahead of us, but I think we really need to better understand human psychology as just as important as the medicine and the vaccine that we're giving people.
So I think when you're in science or you're in a position where science should lead, you're confronted with policy that's against that. It's a real conflict, and it's complicated. And I mean, I think during COVID we saw very clearly in Texas. I think the anti-vaccine campaigns were really strong, and I guess you probably know Peter Hotez, very active.
Yeah.
Voice in the U.S. and the poor man, he was just attacked for every single direction from. So I think that's a responsibility for everybody, not just for those that are in leading positions. But so I want to ask you a few more questions before we open for questions from the audience. But there may be an area where we haven't touched, and I want to ask you, prompt you with a couple of questions, and that is, how do you find the balance for active research, practice, directorship, lab? You also have a lot of different interests in entrepreneurship, which we didn't talk too much, and personal life. And if you talk about aging as an issue, I suppose that I think that for myself, the more time I pass, I want to stay healthier and I want to feel younger. And so how do you put your life balance with all these different activities? What do you do to maintain healthy and stay fit? And what are your hobbies in that area? Okay, and how are they important or not?
We always talk about work-life balance. For me, I love my work, so it's not work. So I think that helps a great deal. I would do this in my spare time. In fact, I do it in my spare time. So I feel very, very fortunate to have the profession that I have and to have the ability and the background to be able to be involved in entrepreneurship and biotech companies or policy or science, et cetera, or running an institution, et cetera. I think that, I've always been careful about managing my time. And I think it's important. Most people don't realize that time is actually a really fixed entity, and that if you want to take on more things and you're already at maximum, it means that certain things have to be taken out. And so really understanding what your priorities are, what your goals are, and how to achieve them, and using your time in the most effective way is perhaps the single most important thing. In addition, you have to have a certain physiology. You have to be able to have endurance. Every day is a marathon. And so controlling the things that you can control. I try to sleep regularly. I exercise every day. I try to eat properly. I don't smoke. I have just one glass of wine occasionally, and things of that nature. And I maintain a positive attitude. I mean, I'm always one that thinks that things are possible. I don't look at things, I don't perseverate on things that are negative or problems that I have, etc. Those are always there. You can choose to, actually confront them and fix them, or move on and focus on those things that you can do that are very positive. So I think possible as opposed to, thinking about the challenges and the problems.
I think that's a pretty good recipe. I think many of us should really follow that. But I'll ask you one more question for you to share. You had a pretty successful career, and that, even if you wouldn't say it, but you'd probably recognize humbly that you've been very accomplished. But when you were back in high school and the first years of med school, did you foresee your career the way it turned out today? Or this is really something that you turn and say, well, wow, this is awesome, incredible. I would not have expected that. What was it like if you're looking at your life in a movie and you're back in, so you're looking at the whole thing. When you were 18, could you have imagined this future?
Not even remotely. I mean, every chapter was a new chapter that I did not anticipate. All I did, the one thing I did, is I put my head down and I tried to do the best job at whatever I was doing at that time. Try to be a good college student, a good medical student, a good resident, a good scientist, and along the way, a good husband and a good father. And I think that, for me, I've trained many people. Some of them are very famous, scientists or heads of institutions or heads of government agencies and things of that nature. And the one thing that they're all different, but the one thing that the successful people had is they had drive, determination. They had a sense of urgency. They always wanted to be better every single day. And they had the humility to understand that they weren't good enough. I never feel to this day that I'm smart enough, that I know what I'm doing, that I'm always feeling like I have to learn more. I have to be better at doing science, at managing institutions, and so on and so forth. I'm learning every day. So I think that part of it is this drive, part of it is the sense of humility, to not recognize that, there are people out there that are better than you, certainly much better than I am. And so for me, that I've seen that as the most important thing. Intelligence, of course, you need a certain base of intelligence. You need some creativity if you want to be a good scientist. But those are subservient to just working really hard. For the students, if you want to be great, just work hard and treat other people with respect. Recognize that in the case of medicine, in the case of science, it's a very social environment. You have peers, you have colleagues, you have superiors and subjugates, and you want to treat everybody the way you would want to be treated. And if you do that, then you'll not only be successful, maybe you'll even be a leader. And you'll be able to actually, make a huge impact because people will want to work with you. Because guess what? All the things that I accomplished because I had amazing people in my lab who, for some reason, wanted to work with me and believed in the science that we were doing. And so, it's really a matter of just being hardworking and being a decent human being.
So I think that's a terrific take-home message. And it's actually very important for us here because as we live in this very competitive world and a more global society, sometimes being on this side of the border, we think it's impossible. You think it's really hard. You say, this only happens in New York or Boston. I truly believe that it can happen here, and we're moving to make that happen. But I think people have to believe that, just the way you said it. So I think I will tape that and then play it over and over. I like that very much.
Thank you.
But I think with that, let me just open the room for questions. And I think we'll have, it's almost 7, but I think, you want to use this microphone?
Okay, I guess I want to ask you, because I find myself a first-year resident in OBGYN, and it frightens me a little to have to face and start working in investigation? How did you break through to the research world?
Well, one of the things that we were fortunately able to do at Columbia is during my third year in internal medicine, I had 5 months to be able to go into a laboratory. So I went into a very good laboratory and I got some experience. And I realized at that point that I wanted to take 3 years off and only do science. Just like in medicine, you have to do full time and train and really get very good at being a doctor. It's the same thing in science. You need to immerse yourself and so on. So I think those who get experiences early in college or in medical school and these research opportunities is a very good correlate for people who end up doing research. So find opportunities to spend even a month or two in some kind of research setting. Could be clinical trials research, it could be translational research, it could be basic research, and find mentors. I was very fortunate in that I had mentors that gave me the courage to actually do what I just said, which is to go in and do science. And I was very lucky. I had gone into one of the very best labs in the world at that time. That was one of the first labs doing molecular biology, recombinant DNA. And we discovered all these oncogenes, and it was a very exciting time. There was no looking back. But I loved clinical medicine, so when I became a faculty member after that, I attended on the wards, 1 month every year and loved it. So I stayed connected with that and so on. So.
Okay, my question is more or less related to that question, but I would like to know how do you choose to do preclinical research or basic research or clinical research? Because I guess for me, I prefer clinical research to other kind of research. But for medical students, I guess they have still to question themselves if they want to do one or the other, or do both.
Yeah. So I think it's mostly exposure. Now, let's say you're doing clinical research. There are many examples of very successful collaborations between a clinician and a basic scientist. I mean, there are some that have led to Nobel Prizes. And so finding that way will give one an opportunity on the clinical arena to gradually morph into and embrace basic science and gradually move their programs towards more basic science and so on. And then similarly, you're seeing a lot of basic scientists, PhDs, that are actually going to medical school and getting MDs or working with physicians to be able to really translate their basic science into clinical and so on. So I'd say that one next easy step is to form collaborative interactions with those that are working, and establish that. There are some really famous examples, Brown and Goldstein and Statins, right? They were very different, physician scientists, and they ended up obviously changing cardiovascular biology and got the Nobel Prize for it. So I think that would be one simple thing. For medical schools, it's very important for students to have the opportunity to do short research stints in laboratories so that they can open their eyes to the wonders of research. You just want to give people exposure. If they like it or not, that's up to them, but they would, get some exposure. So exposure to research early in one's career is, I think, very, very important.
Hello, thank you for being here. I have to ask you, how do you inspire your alumni? How do you inspire those who are working with you and who are learning from you?
Well, I think, I don't know about, so inspiration, so as a CEO or as a laboratory head, I think you want to chart an exciting vision for the future. And so my orientation has always been that things are going to be possible. Like, when we started the Human Genome Project, very famous scientists, some of which were Nobel laureates, said we shouldn't do the project because it was just too hard. Or early, when we said we were going to go to the moon, Kennedy, it's just too difficult. Why are we doing this, right? And what you learn is that when you have a goal, you work towards that goal, along the way, you develop the technologies, you develop the methods and systems to be able to actually accomplish that goal. And that's what happened with the Moonshot, the Human Genome Project, the Human Cancer Genome Project. All of these things were very difficult and not possible to do when they started, but you had an exciting vision. So for me, we wanted to answer important questions. And I would say even more fundamental than that. Most people think that a great scientist is somebody who answers an important question. The really, truly great scientists are the ones that think of what the question is. Some people don't even realize that there is a question to be asked, right? And so I think that you want to think always like a 5-year-old and have this wonder of life and have an open mind and always think that something is going to be possible. So when you do that, you inspire people to do that. But what's equally important is that you have to also set an example. You have to work hard. You have to exhibit the courage. You have to say when you have defeats along the way, you need to convey a sense of optimism that things will be possible and that this is a learning experience, not a setback. And so these are all things that, if you have that, then you can really bring people together to a common goal and achieve that goal, as we did with the MD Anderson Cancer Moonshot.
Hi. I'm Jorge, the former dean that Memo mentioned at the beginning. I really enjoyed this conversation. Thank you for being here. But Guillermo mentioned something that we didn't talk enough. It's entrepreneurship. There's room for a physician scientist for being an entrepreneur. How you do that? And it's really a path for somebody who's in research on that.
I'm an example of that, so I didn't know what to do. And so I think one thing, so first of all, entrepreneurship is the ultimate translation. Because if you have ideas and you've discovered something and it's potentially patentable and so on, and you want to convert that knowledge into something that's going to help people. I often joke that no Nature paper has ever cured a patient. It's only when that insight gets converted into a new medicine, a new diagnostic, a new policy, that things really are, impactful and so on. So it is something that we should all aspire to in some way. And there are different levels of entrepreneurship. Starting a company really requires knowledge. And if you've never done it, you have to connect up with somebody who can be a mentor, who has done it successfully, and they'll know how to, do all of the things that relate to financing and operations and all of the things that are necessary to actually create a company, create a new entity, and so on. And so this is a very gratifying thing, and I was very fortunate to have such great mentors. And in fact, for those who are interested, I actually have a website, and this website, it's my Ron DePinho. That website, I actually have essays that I've written on how to start a company and what it takes to do a company and so on, because I wanted to actually help others, start, et cetera, et cetera. And in fact, that was one of the reasons why I was recruited to MD Anderson by the governor of Texas, was because of my entrepreneurial background. And they wanted me to help start the biotech industry in Texas. And now it's doing very, very well, et cetera. So we're very pleased with that. And it's actually very important. They're really, you need great basic research in an ecosystem. Great basic research, great hospitals, and, innovative clinical trials. And you need the private sector. You need biotechnology, and you need pharma. If you go to Boston, you see all three of those elements. The Bay Area, you see all three of those elements. And they create this feed-forward loop where they make each other better, et cetera. And Houston is getting there, New York is getting there, Seattle, and San Diego. They're now emerging as biotech hubs as well. But it's a really important component. And I would encourage you, Monterey is one of the most innovative and accomplished cities in all of this area of the world. I think, if there's ever going to be, a vibrant biotechnology industry, it's going to have to be here, just because of the culture.
I think we'll take one more question. Sorry, just one more question, and then we'll call it a day. But we can invite him another day.
Talk about telomerase.
Hi, this is not a motivational question, but I would like to know your opinion about CAR T-cell treatment.
Yeah, so I think CAR T is absolutely an extremely important and exciting part of the armamentarium in cancer. And I think there are going to be a couple of things. So CAR T is going to be very important, and of course it's all about the antigen, right? But the other thing is, what's going to be the big breakthrough in this technology is when we can get CAR Ts to work in solid tumors. And there we're beginning to understand why those cells are eliminated so rapidly. And it has to do with the metabolism and the milieu and the tumor microenvironment that are leading to essentially extinction of these cells within minutes, right? So as we solve that, that's going to be a next important step in CAR T. But I'm actually very excited about CAR NK. So Katie Rezvani's work. What's very exciting about natural killer cells, CAR NK, is that those are have much less toxicity, and they're equally effective. And that was actually a project from our Cancer Moonshot initiative. So I'm very excited about that. I'm excited about the myeloid checkpoints. And then also something that happened very recently is Moderna, in collaboration with Pfizer, had really one of the first cancer vaccines that worked. And what they showed with their mRNA technology is that with that vaccine plus T-cell checkpoint, they were able to almost double the responses to melanoma. That's a big advance. And so I think if you can get off-the-shelf vaccines for patients that have specific mutations, et cetera, I think there's a real opportunity to use all of these elements, this whole toolbox, and really make a decisive assault on the cancer problem. So I think the next 10, 20 years are going to be the golden era for cancer therapy. But I'm also more interested in prevention. Up to 50% of cancers can be prevented, and interested in early detection of cancer. And we see the Gallery blood test. That's the first, of many that are going to allow us to catch cancer at earlier, much curable stages.
So we have to have chapter 2 on telomerase and inflammation, entrepreneurship, the future of cancer prevention, public policy, biotech. So I think there are many more chapters. Thank you very much, Ron. I think we are coming to the end, and I think I will have you the last word. So thank you very much.
Agradecemos al doctor Ronald A. DePinho por su participación como ponente, así como al doctor Guillermo Torre y al doctor Manuel Pérez por coordinar la sesión. A continuación, se le hará la entrega al doctor Ronald A. DePinho de un diploma por su valiosa e interesante participación. Así es como damos por finalizada la sesión Gigantes de la Medicina. Agradecemos a todos su presencia.